Alright, so today we're introducing the concept of the unit circle. So the unit circle is a circle graphed in the coordinate plane, okay, with a hypotenuse of 1, where we have a triangle with a hypotenuse of 1 and a circle with a radius of 1. So as you can see, the radius of the circle is also acting as the hypotenuse here. Everybody see that? How it's both? Okay. Make sure you guys are paying attention to this because this part's important to understand the next step. So, we're centered at the origin, and if you were to go out 1 unit each way. Alright, so if we look at this picture, we can identify sine, cosine, and tangent, right? Sine is opposite over what?
Adjacent, or sorry, hypotenuse.
Hypotenuse. So it's y over 1. What is y over 1?
Y.
So sine of theta is equal to y. Alright. And then we have cosine, which is adjacent over. So x over 1 is just
X.
And then lastly we have tan, which is opposite over adjacent, which is y over
X.
Good. Now isn't it true that y is equal to sine of theta, according to what we just figured out? Right here, see that? Sine of theta is equal to y. And what is x equal to?
Cosine. Theta.
So isn't it true that you can find tan of any angle by doing sine of that angle divided by cosine of that angle as well? So that's a new skill that you just learned today. Alright? So essentially, sine is y, cosine is x, tan is y divided by x. What other formula in math is it y over x?
Flipping over the
What if I said y2 minus y1 over x2 minus x1? What does that remind you of? Linear functions. What about a linear function?
Y slope.
Slope.
Why, bro, I was, man.
You were getting there. You were getting there.
I said linear though, I should get at least some
I
credit
mean,
for that.
you get some kudos. Good job. So, yes, the idea is tan is basically the slope of sine and cosine. Okay, that's basically what's happening here. Because if you think about it, this is cosine is your x direction, sine is your y direction, and that's opposite over adjacent is going to end up giving you the hypotenuse. So it's the slant. All right. So in the coordinate plane, anytime you're in the coordinate plane, you have a coordinate x, y. Okay. If you plot that coordinate and you want to find the angle that would give you that coordinate if you were to draw a line to it, if you were to do cosine of that angle, okay, and then sine of that angle, it would give you whatever that point is. So that's the relationship between sine and cosine in the coordinate plane. So cosine is always x, sine is always y. You need to know that indefinitely. And if you ever forget, isn't it true that cosine comes before sine in the alphabet? And x comes before y in the alphabet. So that's the way to remember it. Okay. So let's talk about how this is even relevant, what it has to do with anything. So we have this thing called the unit circle in math, and it's based around 3 triangles. Basically, really, it's just 2, the 30, 60, 90, and the 45, 45, 90. Now with these triangles, this triangle represents 2 types of triangles because essentially, this triangle could also be flipped on its side, okay? And I'll draw you like a little diagram what I mean by that. It could be like this instead. So it's the same triangle, but it's tipped sideways so that the 60-degree angle is here and the 30-degree is here. So the triangle isn't any different, but it's a different perspective. All right, so just keep that in mind. There's different versions of that triangle. So first and foremost, which side of this triangle is the hypotenuse?
The opposite of the
90. This is the hypotenuse, correct? Okay. Now we don't know which one's opposite and adjacent because we don't know which one is our theta. But we do know that this right here, 2, if we're thinking of the regular 30, 60, 90 triangle we learned about the other day, 1, radical 3, and 2, you remember that whole, how we figure that out? I need to get my hypotenuse to be 1. Why does my hypotenuse need to be 1 to fit in the unit circle?
so that you can make it the diameter.
Yeah, well, basically, the radius has to be 1, so I have to make that triangle have a hypotenuse of 1 because the hypotenuse is the radius. So how can I make 2 become 1? I can divide it by, if I'm going to divide one of them by 2, it's going to change the dimension of that triangle. How can I avoid that?
Divide the others by 2.
Divide all of them by 2. So this becomes 1/2. This is radical 3 over 2, and this is 1. So the whole purpose I did this is to get the hypotenuse equal to 1. Now this is not something you're going to have to do regularly in a mathematical procedure. This is just for understanding, okay? So now my hypotenuse is 1. My side opposite the 30 is 1/2. And my side opposite 60 is radical 3 over 2. And you're going to see where this is relevant in a minute. And that would also apply to this little triangle. It would be like this. So just so you know, it just changes the opposite and the adjacent. Over here, this one has a hypotenuse of radical 2. If I want to make radical 2 into 1, what can I divide it by?
Radical 2.
Good, you divide it by itself. So this becomes 1. Now, do you remember rationalization? This is the same thing as radical 2 over 2. So this is 1. This is radical 2 over 2. Radical 2 over 2. So just a reminder, 1 over radical 2, multiply top and bottom by radical 2 to rationalize, it becomes radical 2 over 2. Okay. Now keep in mind the basic degree radian conversions. You remember converting degrees to radians, radians to degrees the other day? Just a reminder. Okay. So this is what we call the unit circle, okay? So I'm going to explain a little bit about what this is. This is basically a bunch of triangles that are 30, 60, 90, 45, 45, 90 triangles inscribed inside of each one of these quadrants, okay? Now do you see all the lines that are green on this picture? Those represent angles that are reference angles to each other. They form the same triangles in each quadrant, okay? The ones in the blue, same idea, all form the same triangles and so on. So let me explain what I mean by that. It looks confusing, but it's actually really simple. So let me show you. What if I take this 30-degree angle and I just connect the center to the side and then I draw a triangle? So you see how I just made a triangle there with the 30 degree? So this angle right here is 30 degrees. Okay, they told us that. Now that means I have a 30, 60, 90 triangle, correct? Because this is 90, which means this has to be 60. So now we know that the hypotenuse of any triangle inside the unit circle has to be 1. So now the dimensions of this triangle are exactly as the one we just did on the previous page, right? What's the one across from the 30?
That would be 1/2.
Yes. This one here is going to be?
Radical 3 over 2.
Good. Now, we're talking about this coordinate here. We want to find what that coordinate is using this information. Now, we know that sine is opposite over hypotenuse, correct? What is 1/2 divided by 1?
1/2.
1/2, that's sine. Sine is y, right? What is adjacent, which is radical 3 over 2 divided by 1?
Radical 3 over 2.
Good. That's how you find sine comma cosine. I mean cosine comma sine. And then, lastly, in this box here, sorry, my voice is like dying right now. This right here just represents the radian conversion, 30 degrees as radians. Okay, remember doing radian conversions? That's it. Pi over 6. So, what I want you guys to do right now is to try to do it for the 45 and 60. And then, if you ever Google unit circle, this is like a known thing in math. Like it's like a tool. It's like the quadratic formula of trigonometry. You're gonna see it on my ceiling a few times. We got a few different ceiling tiles with it. So you guys can easily Google this and fill it in. But I do recommend trying to logic your way through the 45 and 60. And then go ahead and look this up, and you're gonna see the pattern. Okay. So this is your basically classwork for today. So today's classwork, I did one of the angles with you. You're going to finish this unit circle, and you can use the internet as a resource to get it. Okay, you can Google unit circle if you want, look it up, figure out what they are. And then at the bottom of your notes, just a sentence or two, I want you to identify what the pattern is between the different quadrants. See if you can find a pattern. All right, so that's all you have to do for today in class. I'm going to check at the last 10 minutes of class. So I'm going to come around at 10:55, okay, and check that you did that. Okay, does everybody understand? At 10:55 you need to be done with this, but you should be done long before that if you get to work. Okay.